Welcome to podcasting. On Monday, we'll be going over section 7.1 and 7.2, and I'm combining the two of them because they both have to do with solving systems of equations, which you guys have already seen in Algebra 1 and Algebra 2, I believe. So quick review, method of substitution. You solve one equation for a variable and then plug that expression in to the second equation, then solve for that equation for the other variable, and then plug that answer back in to get the value of your first variable. So from our first equation, I will choose to solve for x, though it will work equally well if you solve for y or x. So rearranging this, we can get that x is 7 minus y, and then we take that value, plug it in for x, in our second equation, which gives us 7 minus y equals 9. Negative y minus y is, of course, minus 2y. Equals 9. Subtract 7, divide by negative 2, and get that y equals negative 1, which we then plug back in to either equation to get our result, x plus negative 1 equals 7, which gets us the result x equals 8. We can double check. 8 plus negative 1 is 7. 8 minus negative 1 is 9. Solution works out, and we write that as an ordered pair. So that is the solution to this first system of equations. Now, what you may not have seen in the past, or maybe you have, I don't actually know, are systems that are not linear. We can solve systems that have higher powers of x and y in them. In the same fashion we solve linear systems. It just might be a little bit more difficult, and there could be multiple solutions. Because we have this x squared here, that means that there could be two different solutions to the system. But we can solve it also using the method of substitution. The easiest way to go about this, I think, is to solve this equation for y. So we're going to add y to the other side, add this 1 over here. We get that y is 2x plus 1. Right? And then we can take that and plug that into our first equation. X squared plus 4x minus y, which is 2x plus 1, equals 7. Now we have a quadratic to solve once we distribute our negative. Move our 7 over here. It's x squared plus 4x minus 2x is 2x, minus 1, and then collecting our 7 to the left side as well, we have negative 1 minus 7, minus 8, equals 0. Now we have a quadratic in x that we can solve by factoring. This factors into x plus 4, x minus 2, equals 0. So our possible values for x are negative 4 and 2. Okay. Then we can take those values and plug them in to find values for y. I'll use the second equation because it's simpler. It doesn't have that x squared. So 2 times negative 4 minus y equals negative 1, and 2 times 2 minus y equals negative 1. This first equation, this is negative 8. Add to the other side gets us 7 divided by negative 1 gets us y equals negative 7. Second equation, subtract this 4 to the other side, we have negative y equals negative 5, so we get y equals 5. Pairing those up gives us these solutions, negative 4, negative 7, and 2, 5. So we can solve the system that has the the x squared in it, just like we did our linear systems. It just means that we could have two solutions to our system. Okay. This next one, I would recommend, I'm going to put it up here, and then I'd like you to pause the video and see if you can figure it out by yourself, and then check your answer as I work through it. 3x plus y equals 2, and x cubed minus 2 plus y equals 0. Again, I'm going to solve it by substitution. I will solve this first equation for y simply by subtracting 3x from both sides of our equation. And then we can substitute this in for y in our second equation. That gets us x cubed minus 2 plus 2 minus 3x equals 0. Minus 2 plus 2 is, of course, 0. So we're left with x cubed minus 3x, which we can factor, pull out an x, leaving us with x times x squared minus 3 equals 0, which yields these solutions x equals 0, or x squared minus 3 equals 0, which gives us plus or minus root 3. So these are our possible values for x, and we can plug these into our first equation to get all of our possible values for y. We have 3 times 0 plus y equals 2. That gets us a value of y equals 2. We have 3 root 3 plus y equals 2, which gives us y equals 2 minus 3 root 3. And for the negative root 3, we have negative 3 root 3 plus y equals 2. So y equals 2 plus 3 root 3. So we have three ordered pair solutions: 0, 2, root 3, 2 minus 3 root 3, and negative root 3, 2 plus 3 root 3. And you should always double check these solutions by plugging them back into the original equation.